Hello everyone, welcome to another exciting math problem concerning the limit of a function, which may be a bit confusing for beginners. Here is the problem. Evaluate limit of square root of n squared plus n minus n, where n tends to infinity. Before I uncover the solution, I encourage you to hit the pause button, grab your pen and paper, and give it your best shot. When you're ready, feel free to share your answers in the comments. Then we'll explore the solution together. Let's get started. If you're new to solving limits question, you might initially substitute the value n, which is infinity in this case, resulting in infinity minus infinity. Most likely, you would expect the answer to be 0. However, this is not the case because infinity is not a real number. We cannot determine the meaning of infinity minus infinity because the first infinity may significantly differ from the second infinity in this context. Therefore, infinity minus infinity represents an indeterminate form. This approach is not correct. Now, let's discuss 3 different methods to tackle this question. The first method is more on intuition. We can recall the elementary algebra formula a plus b squared equals a squared plus 2ab plus b squared. Keeping this in mind, we can rewrite n squared plus n plus 1 over 4 as n squared plus 2 times n times 1 over 2 plus 1 over 2 squared, which can be factored as n plus half squared. This implies that the square root of n squared plus n plus 1 over 4 is n plus half for all value of n greater than or equal to negative half. Some argue that as n tends to infinity, there's no significant difference between n squared plus n and n squared plus n plus 1 over 4, allowing us to express it as shown on the screen. Using the result we just obtained, the limit is half. Although this approach seems reasonable, it may lack mathematical rigor. The second method involves the concept of a squared minus b squared equals a plus b, a minus b. Recall that the conjugate of the square root of n squared plus n minus n is square root of n squared plus n plus n. We can multiply the numerator and denominator of this expression by the conjugate. The result, as mentioned earlier, simplified to n. Now, multiply the numerator and denominator by 1 over n. This gives us the following as 1 over n is equivalent to 1 over square root of n squared for all positive n. With this transformation, we can compute the limit in today's question. Substituting the value of n, we get 1 over square root of 1 plus 0 plus 1, resulting in 1 over 2. Using the conjugate is a common technique for finding limits. We mentioned earlier that infinity minus infinity is an indeterminate form. Some of you may recall seeing this from your calculus textbook, known as L'Hopital rule. Our third method involves L'Hopital's rule. But we need to transform the infinity minus infinity form into 0 over 0. Here is how. First, factorize n squared from n squared plus n. Write square root of n squared as n when n is positive. And factorize it again. Many students struggle in this step and cannot proceed. Note that if n tends to infinity, this is of the form infinity times 0, which is again an indeterminate form. So, we multiply both the numerator and denominator by 1 over n, resulting in the following form. After this transformation, we turn it into the 0 over 0 form, allowing us to apply the L'Hopital's rule. Using this rule, we differentiate both the numerator and denominator with respect to n separately. Using the change rule in the numerator, we obtain half times 1 plus 1 over n to the power of negative half times ddn of 1 plus 1 over n. For now, we do not need to perform the technique in the denominator. Here is an important observation. ddn of 1 plus 1 over n is equals to ddn of 1 over n. and thus they cancel out. Substituting the value of n, we get the answer half. So we have discussed 3 different methods to solve this limit. Which method do you prefer? Please let me know in the comments. While we have successfully solved the problem, it's always beneficial to practice what you have just learned. Using a similar method to what we discussed just now, I believe you can solve the following question. Feel free to try it and share your answer in the comments. That concludes today's lesson. I hope you enjoyed the video and stay tuned for more exciting math challenges in the future. Until next time, take care and bye-bye.